how'd you do? I don't know how far you got. How about A? What'd you say for A? 0.6. Beautiful. How about B? 1.6. Repeating? Perfect. What about C? Negative 0.8 repeating? Is that right? How about D? Now D is already a decimal, so we're going to make it a fraction. It is 13/10. Perfect. How about E? 4 nines. Very, very good. I know our first year algebra teachers talk about that a lot. We know that 0.4 is 4/10. 0.4 repeating is 4 nines. How about F? You can type that into your calculator and get a decimal approximation, but there's no way, that's going to go on forever and ever. It's a non-terminating, non-repeating decimal. So we can't change that one. Ooh, what about 0.24 repeating? What'd you say? 24 over 90. For G?
Yeah.
Okay, let's talk about that. Tell me your thought process on that. We have 0.24 repeating, and you said 22 over 90. Tell me your thought process on that.
I misread it. I thought only the 0.4 was repeated. Only the 4 was repeated.
Oh, okay, yeah, that would be a different situation, yep. So what did you, who had a thought on this one? What, oh, Violet?
Yeah. I made it 24 over 99 and then simplified it to 8 over 33.
So let's think about this for a second. Take out your calculators. And we just talked about that repeating 0.4. But just so we can visualize it, take out your calculator and do 4 divided by 9. And you get your repeating 4s, right? So what's 2 divided by 9? Repeating 2s. So think about this for a second. 0.2 is 2/10. But 0.2 repeating is 2 nines. Well, what's 0.24 all by itself? Just 0.24. That would be 24 over 100. So kind of using the same idea, 0.24 repeating would be 24 over 99. Now you sit down with the calculator, so if you're at all unsure, do 24 divided by 99. What happens? 0.24 repeating. So then, like Violet said, we're not done. This is our step 1. This is step 1. But we're not done because that fraction does reduce to what? Let's see, 8/33. Is that okay? And then just to make sure, 8 divided by 33, I'm going to type that in on my calculator. Do I get the repeating 2/4 that I'm supposed to? Yep, so we got the right answer. Is that okay with everybody? All right. Did you make it to the next part, your exponent part? All right. What did you do? I don't even have those A, B, and C. What did you do for the one where they're multiplied? What did you say this was? What's that equal? M plus N. Very, very good. When we multiply x's, we add their exponents. Good, good, good. How about this one? X to the nth over x to the nth. X to the m minus n. Yep, we subtract those exponents. How about x to the m to the nth? What happens there? Double exponent. X to the mn. What's x to the 0? 1. Can anybody tell me why?
Anything to the power of 0 is 1.
Absolutely 100% true, and we need to remember that, but why? Think about this property right here that you just talked about. If you have x to the 8th over x to the 6th, that would be x to the 2nd, right? No problem. What if you had x to the 8th over x to the 8th? Well, you know that's 1, right? But if you do your exponent thing, like you did here, what do you get?
0.
You get x to the 0. but you already knew it was one, so therefore x is 0, it has to be 1. So I got a caveat to that, because somebody said anything to the 0 power is 1. That actually isn't quite true. 0 to the 0 power is undefined. Because if you back up, what happens if x is 0? You will get 0 to the 0. But can that be?
No.
No. So everything to the 0 power is 1 except 0. 0 to the 0 can't be done. All right, how about x to the negative 8? Or negative n? What's x to the negative n? What does that mean? 1 over x to the n. That's exactly right. You good? All right, let's take a second and let's simplify these next ones. And when you get them all done, well, let's just start with the first 4. So A, B, C, and D. When you get them done, come up and put your answer on the board so the rest of us can peruse it. Feel free to talk about them with each other. That's my seating chart. Is it all done?
It's just like really.
We can't get the seating chart done. Okay, well, I know row 1 was right. I know this is right. Okay, you guys have a desk behind you, so you skip the row. You're all, oh no, Sam and Celeste did it right. I think it's just as good as it should. I think everybody else. You didn't even fill it out yet. Okay. So Angie, okay, did everyone else sign it for us? Friends, everybody good on this? Supposed to share. All right, so she's got her answers up here. Let's take a look at them and see what you think. What do you think about these two? They are very, very similar, but they're different. What do you think? Is that right? How about this one? Is that right? Yeah, because the whole thing has to go to the bottom. Good. 125 over 8. Negative 4/9. What would happen if we put that guy in here? Then it would be positive 4/9, right? All right, let's look at some of the tougher ones now. See if we can work through that. Now, there's a lot going on in this problem. And really, there isn't anything you have to do first. You eventually have to do everything that needs done, but I might do it differently than you do it, or you do it, okay, and that's okay. So I'm just gonna call on someone, now that I have my thing. Alberto, what would you like to do first in this problem? This one, there's a lot that needs to be done.
What I did was that exponent 2 I just distributed to the numerator 3.
Okay, so Alberto says that he's got this fraction, it's being squared, so he started with that. He squared everything, all right? So if we do what he says, because he's smart, we're gonna follow his lead, we're gonna square everything. So we're gonna have 4 x to the negative 8 y to the 6th over 9 x squared y to the negative 14. Now you might not have started that way, you might choose to start differently, but is that okay? Fine. Alright, now let's pick on someone else here. Evan? Now, he's already started, we gotta do it, we gotta deal with this. So what would you do now?
What I did is I moved the negatives to the other side of the fraction.
So Evan knows what all good mathematicians know, and that is, we don't do negative exponents. There's only one time that negative exponents are acceptable, and that's in scientific notation. Otherwise, we don't want them. So, let's take care of that. So the 4 and the 9 are good. That guy is gonna come down to the bottom. So think of this as upstairs and downstairs. You got 2 people in the basement already. These 8 are gonna come down to the basement. So now you've got 10 people down there. 6 people are upstairs. These 14 are coming up. So now you've got 20 of them up there. And here's your answer. Nothing reduces or simplifies at this point. So we're good to go. What do you think about that? You all right? All right, let's take a look at this monster. Now again, there is so much happening in this problem. There's a ton of stuff. We have to do something first. So let's start with this one. Caitlin, what would you like to do with this? What would be something we could do?
I would switch them and put the bottom one on the top and then make the exponent a positive.
Yeah. So she says, I know that negative exponents move things. So if I apply this -3 to everything in the problem, everything would move. So she said instead of doing that, I'm just going to move the fraction right from the beginning. Very good choice. And then, probably cube it. So what am I going to have? 2 cubed, 8, y cubed, oh, 7 cubed, is that 3? No, 343. And I think our first fraction is done. Alright, now we got this guy. Does he have an exponent? No. Okay, so here we go. Chloe, what do you think about this? What would you like to do here?
I would simplify the x's and y's.
Okay. While we're at it, let's go ahead and take care of the 14 and the 8. So that would be 7/4. Alright, these are coming down. So x to the 4th. Now these are going up and these are coming down, so I'm gonna have 2 extras on the top. Did I do that right? And that looks like it's done. Okay. Can I do a little cross canceling here? So I can take 4 into 8. And remember how we got 343? That was 7 cubed. So I can take that 7 out and make this 7 squared. So it looks like I've got 2 y to the 5th over 49x to the 7th. How's that? Did I do that right? That was okay? Wasn't so bad. Try that last one on your own. Let's share answers. Anybody wanna volunteer? Mr. Vaughn?
I got y to the 13th over 6x z to the 5th.
That's what I got. Anybody wanna argue with that?
Wait, what was it?
Y to the 13th over 6x z to the 5th. Is that okay? Alright, now we're gonna talk about some intervals and their relationship to inequalities. So, an open interval is simply something that looks like this on the number line. That is an open interval. If this is A and this is B, then we express an interval with parentheses. You guys did that last year? Interval notation is the notation of calculus, so we start practicing right away, making sure we understand. That means all the numbers between A and B, not including A and B. Then a closed interval would be exactly the same thing, but the dots are closed in, which means A and B are included, and we use brackets to indicate that. So if you have to sketch A, this is a number line, this is on the number line, if you have to sketch it, clearly we've got -4 and 5, and everything in between, because that's what intervals are. Since the -4 is bracketed, we'll have to color that one in, and leave the 5 open. That's all there is to it. Alright, that's it. It doesn't get any harder than that. That's what it is. Now, what happens when one of your numbers is infinity? Negative infinity. Well, here's 6, and 6 would be an open dot, because it has a parentheses, right? Where's negative infinity? Clear out here somewhere, right? Don't you dare do this. Oh, do this. This is so goofy. Don't do that. You just know, there's no dot. You just know negative infinity is out here on this end of the number line. So you gotta shade in everything in between negative infinity and 6. So wouldn't that just look like that? And then what would C look like? Same thing. Here's 7. Closed dot. Shaded where? To the right. Now, this is interval, well, this is interval notation. What the problems 9, A, B, and C, those are intervals. You have sketched them. Now you're gonna write them as inequalities. So for example, what would this one say? We'll start with C. C says x is greater than or equal to 7. An inequality has a less than or greater than symbol in it. That's what an inequality is. So what would this one be? B. X is less than 6. And what would A be? Patrick?
-4 is less than or equal to x, which is less than 5.
Bingo. That's it. Where is X? X is in between -4 and 5. Bigger than -4, less than 5. Perfect. Okay, then 11, we're doing the same exact thing, but now you're taking the picture and writing the interval. So what's 11A? What's that look like as an interval? Bracket 4 to infinity. And remember, infinity is always open, always parentheses with infinity. B, parentheses. I wish someone would talk besides me.
-6, and then bracket 2.
Beautiful, thank you. And how about C?
Negative infinity to -3.
And they're both open. what do we mean by scientific notation?
Shortening bigger numbers.
Yeah, it's a way we can deal with great big numbers or little teensy tiny numbers, right? So what does a number in scientific notation look like? Give me an example of a
Like
number.
base of, like with a base of 10.
So part of it has to, so an example would be something like 5.6 times 10 to the 8th, right? That's what it looks like. So I'm gonna say it's A times 10 to the B. Now, there is one restriction. What can you tell me about A, that number, that decimal right there? What can you tell me about him?
It
Violet?
has to be between 0 and 10.
It has to actually be between 1 and 10. It has to be between 1 and 10. So A has to be between 1 and 10. So you have to have one decimal place in front of the decimal point. All right? So here we go. Write in scientific notation. Well, those two numbers are already in scientific notation, so we're just going to multiply them together. So take out your calculator. What is 1.6 times 9? Let's do that part first. 1.6 times 9 is
14.4.
14.4, said in unison. I love it. And then what would my exponent be? I have 10 to the 7th and 10 to the 13th. So that would give me 10 to the 20th. Now, how about I put a 10 in there? So that is what I get when I do this multiplication, but it is not proper scientific notation. That number's too big, right? So I'm going to have to shrink it, make it 1.44. And then I have to decide what to do with the exponent. Now, there are things you might have memorized about, you know, do this, the whatever, left, right, all that. But if you just use your common sense, it's obvious. This is the answer. I have to rewrite it. So whatever I write here has to be the same as that. Well, if this part of the number got smaller, see how I went from 14 to 1, it got smaller, then to keep everything balanced, that part of the number is going to have to get bigger. So however you figure it out, that's going to be your final answer. All right, so with that in mind, let's try B and C. For B, when I combined when I did 1.7 over 3.4, I got 0.5. And then when I did 10 to the negative 5th over 10 to the 6th, I got 10 to the negative 11. How does that look to everybody? Okay? But you immediately recognized, oops! So you had to move that and make it a 5. You know, right? You moved it. Now this time, I made this bigger. So that is going to have to get smaller. So I hope you said this. Is that what you said? I hope. Because since that's negative, smaller would be 12. Alright. Now for the last one, when I did the numbers, I got 30.4. And when I did all of my tens, I got 19. So before we go any farther, is that right? Is that what you got? So we got the same issue, gotta make this 3.04, making it smaller. I hope you said times 10 to the 20th. Perfect. All right, let's try 14. And I'll have you come put these up on the board. So we can look at them and check them over. Okay, this is easy, but just to make sure. Abington, can you put them up there? The answers? Yeah, of course you can. Here. Here, do it for us. Do you need help? You can take him to help you if you want. Or you can go by yourself. I think you got it. Okay, those are going into scientific notation. These are coming out of scientific notation. Back to standard. Okay, for his first one, he put 1.9 times 10 to the negative fourth. You guys back there, you can tell me scope to see that, so I'm gonna read it out loud for you. Is that all right with everybody? All right, you got the first one right, everybody agrees with you. Three point 61 times 10 to the 7. Out of scientific notation, yep, back into standard notation. $5,940. .00594. You all good with that? Alrighty. Perfect. P1 is going to be due on Tuesday. Let's move on to P2 now. Again, remember, we're just covering all the important bases, so this is nothing here is new. All right, here we go. What do we call this guy right here? What's he called? Y-axis. Assuming we're in the Cartesian coordinate plane, which we are right now. At some point, that will have a different name, but right now, it's the y-axis. What do we call this point right here? Origin. That also, name it 3 will have a new name. And then what do we call this guy? X-axis. Okay, so this blackboard is called the Cartesian coordinate plane. And the Cartesian coordinate plane is split into 4 pieces called quadrants. And the quadrants are numbered 1, 2, 3, 4, right? Mathematicians use Roman numerals to number the quadrants, so it's a good habit to get into. All right, draw a scatter plot. A scatter plot is simply plot the points, just plot them. So where are you putting point A? 3, -2, are you putting point A right here? Quadrant 4. 1, -1 is also in quadrant 4 for some reason. Where's 0, 3? Not in a quadrant, it is actually on the y-axis. And -2, 2. All right, absolute value. What do you think of when I say the words absolute value? What do you think of, Charlie?
Make it positive.
When you take the absolute value of something, it becomes positive. It is positive. Okay, yep, what else? Distance from 0 on the number line. Right? Or if we're talking about two-dimensional thing with a vector, the distance from the origin. Alright. There's a mathematical definition for absolute value that we need to know. So we'll get that up here real quick. Oh, guess we won't. So our will start next time. Your homework is due on, what did I say, Tuesday? And I guess that's what I'll see you again, is on Tuesday. So have a great day, a good weekend.